Good afternoon, students. Today we're going to be looking a little bit about how we can architect more complex games. And to help us with this, we've actually pulled in some content, some code that was part of one of the original XNA samples, the game state management example. And it really dealt with several different concepts of state within a game. So let's start by just kind of exploring that content really quickly. The first piece I want to take a look at is this input state class. So this input state allows us to basically keep track of both 4 keyboards and 4 game pads. And remember, XNA was originally created for the Xbox 360, which allowed a maximum of 4 players connected with game pads. If you remember, there's a little plug-in keyboard you can add to those game pads, so they also wanted to support up to 4 keyboards. Now, in reality, we really don't see usually more than one keyboard hooked up to a computer, but in theory it's possible to do with XNA. So the constructor just creates the current state and the last state for both of these. So this should be very familiar from our input coverage, where we talked about how we would basically need a prior and a current state object to keep track of when a new button press was created. And then the update method of this class just does exactly what we did in a lot of our earlier examples, where we assign the current state to be the last state, then we update the state, and then we also have this is connected or was connected that just lets us know if the gamepad was connected that last frame. Notice that they threw this inside of a for loop that's iterating for max number of inputs, which is 4. So this does it for all 4 players. So that part is very straightforward and very much what we've seen before. What's a little bit new is these helper methods. This isKeyPressed method, for example, takes in a key from the keys enum and a nullable controlling player, a player index that is the controlling player, and also has this out parameter where it can put out a player index as well. And basically how this works is it checks to see if a key is down or is pressed, and if we supply a player index, we're saying we want to know, is player 1's key down, or is player 2's key down, or is player 3's key down. So if this has a value, is not null, we are going to look and see, get that player, cast them into an integer, and return the current keyboard state for that player, checking to see if that key is down. Now, if the controlling player doesn't have a value, or in other words, we passed a null, because remember this is a nullable, that's what that little question mark means, then we are going to instead accept input from any player. So we check to see is key pressed for player 1, 2, 3, or 4. And notice too that this out variable is a player index, which is just an enumeration value, but the out means that we're actually going to, what we end up with here is really more of a reference to where that's stored in memory. So rather than copying it like we normally do with a value type, we're actually going to write to that area of memory a player index. So this player index is now a writable link to or reference to that spot memory. And notice that what we're doing here is we're invoking this is key pressed, and we're writing the current player index into that value. So whoever was the one who pressed the key, we are also returning that player index in case we want to be able to know who's been pressing buttons and deciding which controller, for example, should be the one controlling our game. Which is one of the problems with having 4 potential controllers, is that if the player maybe gets distracted, sets down his controller, picks up another one a minute later and turns it on and connects and wants to play with that controller, we need to know that we switched which controller we're working with. And that works for, obviously, these are keyboards, and then we have the same thing for buttons, which is the game pads. So very much the same kind of concept, where if we say which player input we want, we get that in player, otherwise we accept it from any player. And then we have an is new key press, which is just checking to see that current keyboard state is down and the last keyboard state is up, so this is a brand new key press. And the same thing for new button press, so we're checking to see did we press that button down, or are we did we just press the button. So that's the input state. Pretty straightforward, pretty much just a wrapper of the same functionality we've been doing, but now it's dealing with all 4 players at once, potentially. Along with that, they have this input action, which is kind of ties back to when we talked about an input management kind of thing where we wanted to do key mappings and have, for example, a keyboard key and a gamepad button indicate the same thing. So this is actually a public class that we can build an input action to represent an action that's mapped to a particular set of keys or a particular set of gamepad buttons. And notice that it defines 2 delegates, and we're just using these internally, and we'll see how. But if you don't remember defining delegates anywhere, basically what they are is they're methods that we can kind of then pass around. So we have the input action. We're going to construct it, and when we construct it, we supply an array of trigger buttons, which are just things out of the buttons enumerations, the A, B, D-pad buttons and all of those. And then the same thing for keys, so keys off the keyboard that are supposed to trigger that action. And then a Boolean to indicate if we only want to catch that first press, so did it just go down this frame. And basically we store those into the buttons array, so this is basically going through and checking to see if that get those buttons and assign it, and the same for the keys, and that Boolean for the first press only. And now we also have this public method occurred, which we pass in one of those input state objects we just saw, or actually that's a struct, I believe, and then the player, no, actually I think it is a class. Yes, it was a class, my bad. So the class input state, and then we pass in the player that we're looking at, and again this is nullable, so the same pattern. If we don't supply a player, it will tell us which player hit the button or the action that we're looking for. Otherwise we limit ourselves to the player that we specified, and we are going to go ahead and check, okay, if it's only the first press, we're going to check to see that this new button press or new key press, otherwise we're going to test that on the button's pressed or the key is pressed, and then we're going to iterate through these buttons and do our test. And if that button was pressed by the player we specified or whatever, we're going to return a true value. And otherwise, we're going to return a false. So this input action basically gives us a very simple way of wrapping around a key binding, and we'll see how to use that here in a minute. Now, the other big concept that comes in this state example, is this idea of a game screen. So we have an abstract base class, and a game screen basically just represents a single screen. Now, this example actually grew out of XNA. Originally would run on the Windows Phone as well as the Xbox and the computer, and one of the things phones do that other devices don't necessarily do is they tend to really organize things in terms of screens. And part of the concept of organizing things into screens is that you organize all the resources needed to display that screen, and when that screen is not being displayed, if the phone is low on resources, it can actually tombstone is the term we call it, but it basically disposes of the screen it's not showing. It serializes its state, and then it can restore that state and return it to running. Now, in this version of this example, I've stripped out all the Windows Phone code because we no longer have a Windows Phone to worry about. But if you wanted to expand this and use this with Android or with iOS, those same ideas would come back into play. So this you might go back to the original sample if you're looking at doing that and potentially look at how it handled things like gestures and tombstoning. But because of that structure, that's really why this was arranged into game screens. So you think about a game screen as what's going to be displayed to the user at a particular moment, and that could be a menu, that could be the actual gameplay of the game, and you could even take your gameplay and split it up. So you might have mini games, so each mini game would be organized as its own screen, or possibly if your game is a multi-level game, you could have each level organized as its own screen. So there's a lot of ways that you can really work with this concept of game screens. So some of the properties that are defined in this abstract class, there is an is pop-up Boolean property, which basically says if this is a dialogue that doesn't take up the full screen, so you still want to show stuff underneath it, or if this is just the screen that we're working with and it's covering everything else up. And if it's covering everything else up, then those screens are potentially able to be tombstoned, of course, if this is a mobile app. Now with when running on Windows or running on the Xbox, it doesn't actually dispose of those screens. They still are there. They're still in memory. We're just no longer updating them because they're covered. And we have a transition on and off time span, which is just used to determine how quickly we want to show the screen as we transition between, and we can do interesting effects with this. We can actually add some kind of fancy animation or fading to black. There's actually an example of that built into the sample as we're doing that transition. That's also what this transition position is about. It varies from 0 to 1, where 0 is fully on and 1 is fully off, and that is mapped to the ratio of what this transition time would be. And then we have transition alpha, which is just the inverse of that, which is useful if you want to make an alpha value that helps you fade to black or something like that. We have a screen state, which is out of the screen state enum. There's screen state. Right there, screen state. So we have possible values transitioning on, active, so currently being used, transitioning off, and hidden. And that basically just tells us how the screen is being used at the moment. We have this Boolean, which is exiting, which tells us if the screen's in the process of transitioning off. We have this Boolean is active, which tells us if a screen is currently active. This other screen has focus. This is basically, again, it was built around a mobile game, so this would be true whenever you happen to swipe off to deal with a phone call or something like that. Then some other screen would have focus. This screen would not. In a Windows application, this is also triggered if you click on another window other than your game window. So you basically, this is true if the game is not currently what's being focused on. Then we have a screen manager, which we're going to go over that class in a moment, and nullable player index for the controlling player, in case we want to keep track of who is in charge of the screen. Another way we could use this is we could use this for 4-player simultaneous multiplayer, where maybe we have a gameplay screen which is just drawing in one quadrant of the game. We could have 4 of those stacked on top of each other, where each one's using a different quadrant based on their playing index. So that's one of the ways to do kind of split screen gaming. Then we have this virtual activate. This is a hook for us to override. The activate is called basically whenever we start using the screen. So it's basically the equivalent of the initialize and the load content put together. And the reason it's called activate, and we have a corresponding deactivate, is again because of the Windows Phone, because when we have a tombstone screen, we call activate to start it up and deserialize anything that was state that it lost when it was shut down. And deactivate basically is the flip side of that, which would serialize that state. So these are really artifacts from the Windows Phone, but we still use them in the other style of screen management. And you can kind of think of it, this is just a stand-in then the way that we're using it for the initialize method. And the deactivate, we're honestly not really using at all. The unload unloads the content. This is called when we actually remove it from Screen Manager, so when we're completely done with that screen, we want to get rid of any content that it's holding on to. Again, this is a hook that we would override in a derived class. And then we have the update function. So this is the beast. This is what does our update loop part of the loop. Notice we still get a game time like we have everywhere else. We have a couple extra variables, and the reason we have these is because this update gets called every frame for every screen that the screen manager is taking care of. So we may need to know if some other screen actually has focus. So this screen is not actually supposed to be doing anything, and also if the screen is covered by another screen, which means we technically shouldn't be doing anything. So we can use those to kind of make sure that we're in that we know what's going on. So again, here we have that private variable. We just take every update, we determine if somebody else has focus, and set that to that private variable. We have checking that exiting property. If we are exiting, we should be in the transition off state, so that gets updated. And then we invoke this update transition position, which figures out where we are in the process of that transition. And if that returns a true value, that means you've done transitioning, we can invoke Screen Manager remove and get rid of the screen. Now notice that this update, even though we override it, this functionality we want to always be there, so when we override it, we have to invoke the base version of this method. Then we have if covered by other screen, then we are transitioning off. So we need to check if we finished transitioning off or not. If we have finished transitioning off, we are now hidden, and if we're still transitioning, then we're transition off is our state. And then finally, if we aren't exiting, we aren't covered by another screen, we should be active. So we'll update our transition position the opposite direction. Notice we flipped the bit on this last one. And if this returns false, so it's still in the transition process, we're now transitioning on as our state, otherwise our state is active. So this is that update transition position. It takes the current game time, the time span that is how long it should take to transition either off or on, and the direction of that transition either positive or negative, depending on if we're transitioning off, then it's positive, and if we're transitioning on, it would be negative because we're approaching 0 or moving away from 0. And then we take our transition delta, we calculate this to basically, we check to see if the time that's passed in, this time span is 0, then we are at 1. Otherwise, we take the amount of time that has elapsed and divide it by that time variable, and that gives us a value between 0 and 1. That basically gives us the delta that we're going to apply to this transition position. So we take that delta, multiply by the direction, and that should put us where we want to be. And we check to see, did we get to the end? If we did, we're going to actually clamp it to be in the range of 0 to 1 and return false. If not, we are transitioning, so we're going to return true. And that basically handles both directions of the transition, both the transition on, transition off. Math helper clamp, of course, just makes that value fall between 0 and 1. So if we got slightly negative as we were transitioning on, or slightly more than 1 as we're transitioning off, it just makes sure we stay in that acceptable range. Then we're going to handle our input. This handle input is similar to the update. The difference is this only gets invoked for the active topmost screen. So the first screen that's active is going to have this called, and notice it gets an input state object passed in. The rest of the screens do not get any input. They don't get this handle input called. So this is really where you want to handle player input. And the nice thing that comes out of this is only one screen will ever get the player's input at one time, so you're not accidentally updating the game underneath a menu or something like that. And then we have the draw, which of course is doing nothing in the base class. We have to override that to add custom drawing for our screen. And then we have this exit screen, which basically just checks to see if the transition off time is 0. So if we're not having any kind of delay in our transitioning off, we immediately remove the screen. Otherwise, we set that is exiting property to true. Then we have our screen manager class, and this is basically maintaining a stack of screens that we want to just be displayed. So the topmost one is the one we usually want displayed. So we have a list of screens. We also have this temporary list that we use to kind of unstack and restack as we're processing things. Then we have a content manager, which is specific to the screen manager, and we have the input state. The screen manager keeps track of that. Now notice that this is implemented as a drawable game component. So as a drawable game component, we know it has to have an update, it has to have a draw, an initialize, and a load content, as well as a dispose method. So we also create a sprite batch property, and because every screen ends up getting a reference to the screen manager, they can all share that sprite batch and use that sprite batch. It saves us from having to create a bunch of those. The same with the fonts, the same with this blank texture, which is just 1 pixel square, a couple pixels square that we can use to color things. Then we have our constructor. We create our content manager, and this is all it takes to create a content manager. It is takes the game.services, which is one of those service providers that was in the reading, and then the directory that content is stored in, which means we can actually have separate subdirectories for different contents from different parts of the game, if that helps with our organization. Then we have our initialize method, which notice invokes that base initialize and sets this initialized is to true, and that's helpful because that is initialized basically tells us whether or not this game screen has its content manager potentially created. And then we have this load content, and we're creating the sprite batch, we're creating our font, and creating a text, that blank texture. And then for each screen and screens, we're calling screen activate. So every screen that's already been added to the content manager, we activate it, which is a combination of initializing and loading content. And for unloading, we just iterate through all the screens and tell them to unload their content. And then for the update, we read in our input. So that update method of the input, again, takes the current input, makes it the prior input, loads the new input. We clear the temporary screens list, and then we just re-add all the screens in our screens to that list. And then we're going to iterate through the temp screens list instead of the real screen list, so that if we remove screens from the real list, we're still iterating through them in order, and it helps avoid those problems where we're actually tweaking the thing we're iterating over as we're iterating over it. So inside this while loop, we pop that topmost screen, and then we remove that topmost screen. So we're basically treating the screens list as though it was a queue. So we're treating it like a queue, but we're still using a list, which gives us the ability to index things by their actual index value. But basically envision that as a queue. Then we call update for the screen that we just popped, and remember we have to do that for all of those. And then we're checking to see if the screen state is transitioning on or active. If that's the case, then this screen should be active. So we're going to check to see if this other screen has focus has been changed yet, and remember it starts at false. And if it has not been if nothing has been active yet, nothing has had focus, then we know this is the topmost active screen. So we're going to invoke that handle input, and we're going to tell it set that other screen has focus. So every subsequent screen is told somebody else has already got focus. And then if this is a pop-up, if not a pop-up, remember this is our first active screen, then all screens after this are going to be covered. So we're going to set that covered by other screen to be true as well. And notice that if the game is not active, so if the game itself has lost focus because we're on another window, this starts as false. So it means none of these screens are active. So that handle input never gets invoked for any of them. And they all get updated with that other screen has focus value and that covered by other screen. So basically this loop is just a fancy way of making sure that we only ever call handle input on the uppermost screen, and we tell all screens as we update them whether or not they are the currently active screen. And then our draw method is pretty straightforward. We just iterate through all the screens, and as long as that screen is not hidden, we are going to invoke its draw method. So that way if we have screens that are sitting on top of other screens that are pop-ups, so they are not hidden, but we have two screens that should be showing, we render both of them in order. And then we add screen method basically takes a brand new game screen and a player index who should be controlling that, which again is a nullable. So if we want any controller to be able to control that, we just pass in a null. We save the controlling player. We set the screen manager to be this object, so this screen manager that just got added to, and we also tell that screen that it's not exiting. And then if we have a graphics device, we also invoke the activate at that point. So basically as we add screens, if we've already been activated, if we've already loaded our content, then we immediately will load the content of the other screens. And then we just add it to that screens list. So it's at the top of that stack, if you will. And then when we remove screens, we unload its content. We remove that screen. Notice because it's a list, we can pass in the actual game screen and we'll find it in the list and remove it, even if it's not the topmost, which is why we're using a list instead of a stack. And then we have the temp screens list. We're also going to pull it out of that one in case we're iterating through and need to get rid of it if we're in the middle of things. And then we have the ability to return these as an array. It's just may be helpful in some places. Then we have this helper method for fade to buffer to black. So this basically takes in an alpha value and draws that blank square black times the alpha. So as that alpha gets stronger, deeper and deeper black, and this would draw over the top of whatever is already being drawn. And then we You have to deactivate and activate. And this activate method returns a false to indicate that we're not tombstoning, because on Windows and on Windows and Xbox we never tombstone, so that's what this is. If we were dealing with phones, we'd have to actually add a little more to that to figure out if that screen is actually being transitioned activated because it was tombstoned, and if that's the case, this would return true to say we've got to reload everything and we've got to set up our state. Okay, so that's Screen Manager. Screen Factory is just an interface that allows us to create a screen of a specific type. So this could be useful if you have a very complex game and you want to be able to just create screens from the type of screen at the drop of a hat without necessarily invoking the new constructor. The real reason this is around is from that using a mobile game again. This factory was used to basically restore tombstone screens. And let's see, anything else? So that's the whole of this screen state management folder. So let's talk a little bit about how that's actually implemented in the game. So in our game, notice we create a screen manager and we create a screen factory, which is an implementer of that public game screen create screen. And because we're just using, we're not dealing with tombstoning, we can just immediately return this create instance. This activator basically just invokes the constructor of whatever type we passed in, and then the result is an object that we get back, the initialized object, which we cast to a game screen and then return. So very simple factory. If we were trying to deal with tombstoning, this would have to be a lot more complex, because it would deal with the deserialization of the save state. Then we have our, in our game, we were in the game. So we just set that up and added as a service so that we could access it from anybody who has access to the service container. And then we create our screen manager. Notice we pass in the game because it keeps a reference to its game as a game component, and we add it to the game's components list. Now that it's added, that means we don't have to initialize it, we don't have to invoke its load content, and we don't have to call its update and draw. Those will all be handled by the base class game because it's going to iterate through everything in the components collection and call all those in turn. And we can see that here in the initialize, we're doing nothing extra. Load content, we're doing nothing extra. Our update, we are doing nothing extra. Well, actually, I don't really want this in there. This is exits as soon as we get exit or escape hit. I want to do that a little differently, so I'll just strip that out. And notice we have this base.update, this base.initialize. Those need to be there because that's what actually causes it to go through all those game contents. And then we do have the clear to cornflower blue, and then we call the drawing. So all the drawing is handled by the screens as well. So the game class actually ends up being very clean at this point. And the big thing that we have is this helper method add initial screens, which is adding to that screen manager a background screen and a main menu screen, and that's being invoked from our constructor. So nice how a game component can really clean this up and make it a lot less complex. And then these screens are defined in the screens folder. So these are examples of game screens. So overriding that state management.game screen that we looked at, and let's just look at a very simple one. So this background screen. So this screen is loaded and uses to display a background that basically is always going to be there. So this is the very first screen loaded. So if we exit out of everything, this screen would be there. And it has a transition on and off of 0.5 seconds. Notice that it does inherit from game screen. We also set up a content manager. So one of the patterns you'll see in these screens is they all create their own content manager. They don't use the one from the game. And the reason for that, again, was tombstoning with the Windows Phone. If you're trying to free up resources and the content of a game is really the biggest resources we deal with, then it makes sense to separate the content manager so that each screen maintains its own contents, and if it ever gets tombstoned, it can dump all those contents and free up all that space. So then it also has that background texture that's going to display. When we activate this, we create the content manager. So again, same style we saw with the game screen manager, or the screen manager, to create a content manager where we pass in the service collection and the content, and that's how it can get the graphics device. It actually queries this services for the graphics device when it's ready to use it. And then the background texture we go ahead and load using that content manager we just set up. Notice that we check to see if that content is null. So basically, if we're activating for the first time, we're going to create the content manager. Every time after that, we are just going to use the already loaded content manager. Now you might be wondering, isn't this going to end up being a lot of memory allocation? But the content manager is actually really nice. It only loads the content once, and it stores it in a dictionary, a cached version of it. So every time we invoke content load with the same identifier, file identifier, in the future, we get the already loaded object just immediately returned. So this actually doesn't hit us with any real meaningful penalty in terms of computation to actually invoke it multiple times. Then we have the unload, which is just going to invoke content.unload, which tells the content manager dump all the content that you've loaded, free up that space. Our update just calls the base update, so there's really no reason that we need to have this other than notice that instead of passing on this covered by other screen, we're just returning false. So the real reason we're doing this is to tell the screen that you're never covered up by another screen. So it will always draw itself. And it will never try to transition off. And then we have the draw. So with the sprite batch, we load the sprite batch. We just grab the one out of our screen manager, so all of these screens share the same sprite batch. We get the viewport from that as well, and we compute the bounds of the screen, so 0, 0, the viewport width, viewport height. We start drawing with our sprite batch. We draw that texture, and we also add these transition colors, and then we end. That's really all there is to it. So the color is just based on that alpha. Background screen, very simple. And then we have some basic other types of example screens. Gameplay screen, this is just a placeholder for what you do for game content. So again, it sets up a player and an enemy, which are just random graphics. We load a font. We pretend it takes us a long time to load using thread.sleep, so this basically keeps this from loading for a while. And then we reset the elapsed time once we start, just to make sure the game doesn't have that 1,000 millisecond sleep time loaded up as how much time has elapsed in the frame. And then we deactivate, content unload, those look very much the same. Update, we're just basically bouncing the text around to show something interesting on screen. Handle input, we're looking for if the input says anything, if the player has gotten disconnected, if we have this pause action, so if the player hit the pause button, if you will, then we're going to add this pause menu screen on top of the screen manager, which is now going to show a pause. Otherwise, we're just jittering the stuff on the screen, and then we draw all those positions. There's one thing I want to tweak. So if we come up to this pause action, so this is that keyboard and button mapping idea. Notice again, we're passing in the array of buttons that we want to have invoke pause. So either the back button or the start button on the Xbox controller, or the backspace key on the keyboard. I'm going to also add the keys.escape, because that's pretty normal, that we'd expect when we hit the escape key we would pause the game and potentially go to the main menu. So that adds that to that input action. And notice in our update, our handle input, we are checking to see right there, if that pause action occurred. So if we hit the pause button, we're throwing that pause menu screen up on top. And that menu screen, pause menu screen, is actually extending menu screen. So let's take a quick look at this. So this is kind of a quick and dirty menu container where we have basically the idea is a stacked menu of text, and you can move up and down those options, select an option, and cancel an option. So all these are mapped to input actions. And then we have a list of menu entries, which are these menu entry objects. And take a quick look at those. They basically have text which is going to be displayed, a little bit of information about transitioning effect and where they're positioned on the screen, and an event handler for when they're selected, and the constructor which takes the text they're going to display, and then an update method that basically invokes if they're selected or not, and then how they should be fading in and out if they are selected. And the draw, same thing. They're doing some pulsating effect to make them look nice. And then we can also get the information about the height of the font and the width of the font that we're dealing with. So inside that menu screen, we have the transition on and off time. We have these input actions that we're creating for example, moving up the menu, either the D-pad or the left thumbstick, and then also the keys up, and then down for iterating down the menu, for selecting something in the menu, the A button, the start button, the enter, or the space key, and then for canceling the menu, the back button, the back key, and we'll go ahead and use the escape key as well. Then we have our handle input, which is basically checking to see if any of these occurred. We have this selected entry, so which entry we're looking at in the menu, and we switch which one that is based on when we hit menu up or menu down, or when we select, we invoke the onSelect entry, and if we cancel, we invoke the onCancel. So the onSelect entry basically invokes the onSelect entry for that particular menu. The onCancel, we just exit this menu screen, and we also have an overload on this so we can use it as an event handler, and this virtual helper function which updates menu entry locations to make sure that they're positioned correctly on the screen. You can dig into that if you want to take some time, and then updating and drawing. So all of that is built into those menus. So now if we look at that menu entry, or sorry, the pause menu is a simple version of this. Notice we create a menu entry for resume the game, for quit game, and if we select resume, we invoke the onCancel. If we quit menu entry, and we add those two. So if the quit game menu is selected, we ask and use a message dialog box screen, so basically a pop-up that displays this message, are you sure you want to quit this game? If they accept, then we invoke this loading of the transitioning back to the main screen to get us back there, or we just go back to the screen that we're on with the exit. So all the menus kind of work like that. The main menu screen actually has a number of options and shows some abilities to play with those in different ways. Rather than digging through all of these, I'm going to leave that for you to do. But let's just go ahead and take a look at what this looks like when we run the game itself. So we start, we have our main menu, and notice that it's rendering the title of the menu, and then we have these three options. And notice too that we're making it very clear which one of these is actually the currently selected option. It's very important in a game that you distinguish clearly which one is the active option so the players know. So for example, if we look at the options, this opens this options menu, which is the options menu screen here, and this just shows ways of kind of separate rolling through a list, or turning on and off Boolean properties, or incrementing. So there's just different ways you can play with that menu idea. You'll probably want to replace this kind of concept with one that's more specific to your game, but this kind of just shows you the way that you can get around it. The play game is actually going to basically push two things onto the stack. There's a loading screen, and then that loading screen is also loading the gameplay screen. So this way, loading screen displays while the gameplay is doing that loading. Remember, the gameplay had that delay, so it's going to take a little while for this content manager to load, and then we see how silly the content is. But yeah, this loading screen, let's take a quick look at that one. Basically, it takes in a screen manager, and then it takes in an array of screens that we want to load, and has a transition time, and basically it's going to load all those screens, and once they have loaded, let's see, where's the... we invoke it with this load method. So we basically get to add screens that we want to load. For each screen that are all the screens in the game manager, it actually transitions them off. So this may be something you want to tweak in your game. You may not want to use this in the form it is, but this basically gets rid of everything that was previously loaded and starts loading all these new things that we asked for in the order that we've asked for them. And that's why in that main menu screen, when we actually quit the game or return to not main menu, pause menu screen. When we return to the game, notice we're actually invoking the loading screen and reloading the background screen, the main menu screen. So that's one way of doing it. Another way is just to take them on and off the stack rather than reloading them, which actually is better if you're not on a phone. So this is not necessarily the greatest example for a PC game, but you can play with it and look at these and just get ideas for how to actually work with this. Then finally, if we actually choose the exit option, it's just going to invoke game.exit, which is, if we hit confirm, going to close the window. So that was a whole lot of stuff, and you can sure dig through this, spend some time, get familiar with it. These screens, like I said, these are all just kind of quick and dirty examples. They're not necessarily the best organized for a PC game. They were definitely built around the idea that this is going to run on a phone. But let's go ahead and add our own custom screens. Just add a couple so we can get a feel for what that looks like. So the first one I'm going to add is just going to be a splash screen. So a screen that displays static content, or potentially you could make an animated one, just for a set period of time when we start up the game. So you see these companies use them to display their logo, stuff like that. So we'll just do a splash screen and add it to the screens folder. And we'll make this public, and we're going to extend the game screen that's in the state management folder. And of course I didn't type in the using, so let's get the using up there. And then we're also going to need Microsoft XNA framework and Microsoft XNA framework content and Microsoft XNA framework graphics. Okay, so for this splash screen, we want to override the activate method, and we're going to use this to actually load our content. Now the base method really doesn't do anything. If we go back and look at that game screen here, it's really just a placeholder as well as the deactivate and unload. So we don't necessarily have to call this base.activate, but if you're ever uncertain, you can just leave it in. We'll do if content, because we need a content manager. So we'll set up a variable for that. And if that equals null, so if that hasn't been created, we're going to create it. And the content manager needs to have a service provider, which we can get from the screen manager. So we're calling the screen manager property of the base class game screen, and we can call its game property. And then that has a services property, which is a services container. And the second thing we need to provide is where our content is located, what folder that's in. And then we'll go ahead and content.load a texture 2D, which is going to be our background. And that is splash, so that's some content I've preloaded with this splash.png. So we'll set that up, and we need to save that to our background. Then we need to override our draw, which takes a game. And that should be an override. And when we override this, basically what we're going to do is just use the sprite batch that's in our screen manager to draw that. So we'll go ahead and begin and end. And in between those, we will render that simple background. So sprite batch.draw, our screen manager, sprite batch.draw, and I'm just going to use the texture, which is our background. And I know that this is the same size as my game right now because I drew it that way, so I'll just use vector2.0, and if you might want to scale it to fit your game if you're using something else, and then color.white. This is just a very simple example to get a splash screen showing up on the screen. We'll jump to our game, and when we load our screens, we'll just add another screen on top. So these are loaded and basically in the order we're pushing them onto the stack. So we start with the background screen, then the main menu, and over the top of the main menu, we're going to add our splash screen. And we use null to say that we don't have a player that this is actually a part of or belongs to yet, so you don't really need to worry about that. We'll go ahead and run this. And what are we getting here? Exception. Content file was not found. Oh, because I need to build or make sure that this isn't our content project. I bet you it's not. Yep, so I'll go ahead and add that. Splash.png, and there we go. Build that. Now if we run this again, should start with that splash screen displayed. There we go. So right now, that's just going to display. There's nothing to tell it to transition off. So it's going to stay displayed forever. So it's not really what we want. We want it to just display for a limited amount of time. So I'm going to go ahead and add a time span. We'll call this display time. And let's go ahead and set that to, actually let's do this in the activate. Display time equals time span dot from seconds 2. So we want this to display for exactly 2 seconds. And then I'm going to override the handle input. Remember, handle input is only ever invoked when this screen has focus. And again, if we go look at that game screen, the handle input is just a hook method. There's nothing there, so there's no need to invoke the base method, but we certainly can. It doesn't hurt anything, and it might be a good practice if you don't like to go and check and make sure that it's okay to do so. So basically this is invoked when we know for sure our splash screen is actually active. It's the topmost screen that is actually active. And in that case, we want to take that display time and we're just going to subtract the game time dot elapsed time. So subtract a time span from time span, and then we'll check to see if display time is less than or equal to time span dot 0. So if this is negative or 0, we're going to invoke exit screen, which just starts that transitioning off process. Because we haven't overridden or reset the transition off time, this is just going to immediately transition off. So the screen will show for 2 seconds, boom, it's gone. If you want to do some kind of fancy transition effect, you could go back and add that, but we're just doing the very simple version of this. So we have our splash screen, and it should be up for exactly 2 seconds, and then we're to the main menu. So when it transitions off, we transition on the screen underneath. Also notice part of the transition of the menus, they have the menu slide in from the side, so kind of a little quick effect that looks pretty good. Alright, we'll go ahead and exit out of our game. That's our splash screen. I'm going to do one more example screen, and we're going to load this NASA video liftoff of SMAP MP4. So in order to use this, we need to make sure that we add it to our content list to be built, and it's going to be built, if you look at it, using the H.264 because it's MP4 video, and be processed with the video processor. So this is basically a way of bringing in a cutscene. And to do that, we're going to also create a new screen. We're going to add a new class, and we're going to call this Cut Scene Manager, or sorry, just Cutscene Screen. We'll make this public, and it's going to extend the game screen. And make sure you use game screen, not gameplay screen, or it's not going to work the way you expect. We need to bring in a couple more using statements. So using, in this case, Microsoft.xna.framework we're going to use, and then we're going to use Microsoft.xna.framework.content because we're going to create a content manager in here. And then we also need the Microsoft XNA framework media, which is where all the video stuff is. And finally, the game architecture example state management so that we can get our game screen base class in there. So we're going to need a content manager, just like we did in the other one. We're going to need a video, which comes out of that media, and then we're going to need a video player to actually play that video. So those three things. Let's go ahead and create a constructor for this one. So public cutscene screen. And when we create it, we'll go ahead and, well, actually, we can do all this in the activate. So we'll just override the activate again. And again, we don't actually need this base because the activate doesn't do anything. So in this case, I'm going to go ahead and take it out. So the last one I left in just to show that you can. It doesn't cause any problems. This one I'll show that you can take it out. We want to make sure that this content is not null. Oh, that's why I wanted a constructor. That's right. We'll come back to that. So if content, sorry, not is null, that means we haven't actually loaded. And yeah, I guess we could do this all in here. So content equals a new content manager and screen manager dot game dot services content, and we need to load a video. We also need to create a player. There's not a reason to constantly be recreating the player, so I'll go ahead and do this in this if statement as well. So basically, we only create our video player once, and we can actually do that in the constructor. It doesn't rely on the graphics subsystem, so we could actually do it elsewhere. And then we'll just go ahead and do the video equals content load. We're loading a video, and our video name is liftoff of SMAP. And of course, this could be put in here as well because it only needs to be done once, since we're not worrying about tombstoning as a mobile game. Okay, so that's our activate, and then we need our update or our handle input. So let's do the handle input. So if we get into this handle input, and again to show that we can get rid of these because they are just not really doing anything specific, this only gets triggered if we are currently active. So I am going to actually do two things. I'm going to add a Boolean for playing, and that will be initially false. And then we'll check to see if we're playing. Or actually, if we're not playing, then we'll go ahead and tell our video player to play our video. So anytime we start receiving input, if we're not playing, we start playing, and we'll set that is playing to false. And we'll override the deactivate as well. So we haven't used this before. Again, if we look at the game screen, the deactivate is just a placeholder. It doesn't actually do anything at this point. But this would be invoked whenever we lose focus. So if, for example, we clicked off the window, and if that's the case, we probably want to stop our cut scene. So we'll do player dot and it doesn't have a pause, it just has a stop, but that doesn't actually change the play position. So we'll just go ahead and leave that at that point, and we'll also set that is playing to false, and the next time this handle input comes back and is triggered, we'll pick back up. So that should restart our video where we left off. And now we just need to do our drawing. And again, we don't actually have to invoke this base method because it's just a placeholder for this hook. But what we're going to do in here is we want to draw the current frame, whatever the current frame of the video is. And we can get that from our player. So we're actually going to do screen manager.spritebatch.begin. And then we're going to draw a particular frame out of the video. And we can get that from player.getTexture. And that's going to be whatever frame should be shown right now. That's what we're going to actually get there. And then I'll just play this, place this at the upper left-hand corner. Now this is not sized to the screen, so it's actually going to be partially off-screen. You could do some logic and try to get it on screen, but completely, but enough is showing to really get our example working. So that's all I'm going to do here. Screen manager spritebatch.end. Okay, so when we run this, we're just going to grab that current frame. Now the audio is actually handled in the background by the video player itself, so we don't need to worry about the audio. As soon as we tell it to play, it's going to play the audio track, and then every time we update, we have to actually pull out what should be showing on the screen and use that texture to show. So this is a little bit more involved than most multimedia applications because we don't get a nice control that we just drop in. We're actually having to deal with the raw frames of the video ourselves. But that's pretty straightforward. And then we want one more thing that we're going to do when we handle this input. We want to make sure that if the player dot position, play position, so how far we are into that video, if that's equal to the video dot duration, so these are both time spans, so if we've reached the end of the video, we want to go ahead and exit the screen. So once the video is done, we'll transition off. Okay. Now, where are we going to play our cutscene? I'd like to play it when we first start the game. So when we look at this main menu screen, we have play game entry selected. This is what actually starts the game. And notice that we use a loading screen. And the loading screen, if we take a quick look at it, and we've already talked about this, but this load method takes a number of game screens that we want to load. And notice it's using the params keyword, which means these can actually be just a comma delineated list of additional parameters. So if we go back to game, where were we? New gameplay screen. We can go ahead and add a new screen here, which is going to be the next parameter passed in. And let's do a new cutscene screen. So that should load our video, play our video. When the video finishes, and we should then fall back to the gameplay screen. So let's see if we got that in the right order. So we have our splash screen, and looks like I did not put them in the right order, so we're going to swap these. So we're going to do the cutscene screen and then the gameplay screen. So again, we have our menu, play game, we have our loading screen, and current state of the object. Did we not get our video? Our video is null. So when we first hit, actually let's, instead of doing this here, let's move this up here. So immediately after we load it, because I think that handle input got invoked before our activate, potentially. So we'll play and is playing equal true, and there, because the activate will also get triggered when we come back from pausing. See if we got that in the right order, and did that. 10, 9, there we go. 8, 7, 6. Except, let's see, the video duration, that first time it loaded it was actually at 0, so we need to say is playing, and so we can actually not transition off immediately. And it helps if I don't type too fast. It is not behaving correctly. Let's see, let me jump back to my notes and see if I did something wrong there. I definitely did it in the handle input. So if not is playing, we want to start playing and set our is playing to true. If not is playing, let's make sure that's false to begin with. Yep. And I guess I did the other one in the update. And in our update, we do want to invoke that base because that has to do with the transition. So it actually needs to be there. So the play position is greater than or equal to video dot duration. Wonder if I had my, I think I might have had my comparison the wrong direction. So let's see. And player at this point does not have a video. Let's see, because this needs to check. That's right. That's the other reason we want this is plain Boolean. So if we haven't told it to play yet, we are not going to try drawing it. There we go. Wait, what am I missing? Go back through my notes. Is playing. And the update, if the play position is greater than or equal to the video duration, exit the screen. The deactivate. We have player, oh, we do have player.pause. I didn't see that one, but apparently it's in there. Okay. And load the video. Content upload, liftoff. The only other change that I have in my notes is I actually did create a constructor. So public cut screen scene, and I actually initialized the player there. So video player, maybe it just needed to be loaded up sooner. Well, we're just immediately transitioning. That's... Or are we? Maybe this is in the wrong order. So, menu screen. Let's put our cut screen back after this. There we go.
9, 8, 7, 6.
So we have this nice video from NASA.
3, 2, 1. Start and off. Global observation. Climate point.
And we'll let this play through. Couple minute video.
We have 46 seconds. Good. 3 seconds in, max 2. Vehicle 1. Dynamic pressure in the 7 seconds. Chamber pressure beginning to decline on the solids. Expected. And we have burnout of the solids. We'll be holding on to the solids for about 30 more seconds. For a safe water at point. Then at 12 seconds. Still looking good. 1 minute 25 seconds. Chamber pressure in the main engine and in the 30 seconds. Getting by for separation. We have separation. Solid rocket motors. The altitude vehicle now only weighs half of what it did at launch, spelling a rate of 799 pounds per.
Okay. So that shows how we can get that loading sample to play that cutscene. One slight improvement we might want to make is you may feel that that was rather long and you want to be able to skip it in the future. So let's go ahead and add one of these input actions here for skip. Allow us to skip ahead in the video, and in our constructor we will construct that input action, and it's going to take a array of buttons. We'll use the initialization syntax to say which buttons we want that to be. Let's do buttons.a, and to bring these in we need Microsoft XNA input. So Microsoft XNA framework input, buttons A, and then for keys we'll use new keys array, and I'm going to use the escape key. As well as the, actually let's just use space and enter. So those are the two that we have been using for interaction up to this point. And go ahead and say only needs to happen first press, because what we're going to do with that input action down here in our handle input is we'll just check to see if skip dot occurred. We pass in our input state object. So this occurred is going to test to see if that occurred. We need to say which player we care about, or if we're passing in null, then we need to have a player index object to pass in. So we'll say null and then player index. So whatever player actually ends up hitting that skip key, they get assigned to this player index player, which we don't actually care about. We just kind of throw it away in this case. And that also needs to be an out variable to say that we want to write it. So this actually will, when we call this method, whatever value it gets for the player actually gets written back to this variable. That's what that out actually means. So then we have access to what player actually was the one that pressed the button here. We don't actually care, so we'll just leave that alone, and we'll call exit screen to go ahead and close the screen early. So now if I run this again, and once I get past my splash screen, I say I play the game, go through our loading screen, I hit a skip button, I immediately jump to this screen, but notice one of the other things we didn't do there. We want to probably go ahead and stop our video so that we don't have that audio still running in the background.
Yeah.
And there you have it. We can skip through our cutscenes. So this is kind of some different ways we can organize our games into these types of screens. Like I said, you might want to tweak this a bit for your own implementations, but if this would be useful to you, it's a really nice way of organizing your game, and really provides some easy ways of kind of dropping in. So, for example, we might have multiple gameplay screens for different mini games, or might actually create a different screen for each level if you're doing a multi-level game. There's a lot of different ways you can play with this and actually build something interesting. So we'll go ahead and stop there, and have a good one.